So in this video I'm going to be talking about the complex exponential function e to the power of z, and we're not going to be doing a lot of calculations here. We're just going to be kind of visualizing what this function looks like and how it works. And to do this I need two coordinate systems, one for the input coordinate z and one for the output coordinate w. So we'll make a mapping of z into w by this function here. And in order to investigate what happens when I plug in different numbers on z's place, let's try to look at some special cases. For instance, if z is a real number, or in fact, let's say z is a positive real number, then let's include 0. Then we have z here on the real line over here. How would that be mapped into w? Well, e to the power of 0, that's just 1. So that maps over here on the real line. And any real power of e is just a real number greater than 1. So you can say that the positive real axis over here is mapped onto the positive real axis in the w domain, except for this interval 0 to 1. What then about negative real numbers in z's place? Well, if z is a negative real, then e to the power of z is just e to the power of minus the absolute value of z, and that's the same as 1 divided by e to the power of the absolute value of z. And so that's a number, this number here is less than 1 and greater than 0. So the negative real line over here is mapped onto this interval here in the w domain. What then if z is some imaginary number? Let's say that z is a positive imaginary number. Well, in that case, z is just purely imaginary, and we can write it as I times y, where y is some real number, and e to the power of iy is then 1 times cosine of y plus I sine y. And this is a number which has a modulus or absolute value of 1, and y here, that's the argument or the angle. So obviously we are on the unit circle because the distance is constantly 1, and as y changes, then the argument changes. So this actually describes a circle on the unit circle. It's supposed to be a circle here, going all the way to pi as our z value goes to, well, pi somewhere up here. So let's just mark that by a triangle here, and we'll do the same over here. And if z is a negative imaginary number, so it's here on the negative part of the imaginary axis, then obviously z can be written as minus I times y, where y is a positive real number. Same thing over here actually. And what we get is, again, the unit circle all the way to minus pi. Let's put minus pi down here. Oh, sorry, minus pi I. And we can mark that with a triangle here. Do the same thing here. Of course, you could have a number that goes on further than minus I pi or I pi up here, but then you would just continue around the circle and you would map points that have already been mapped, so to speak. So let's say I have some numbers here on this line, which is supposed to be a straight line going through 2 on the real axis. How would this line be mapped? Well, since the argument changes from 0 to, let's just say, pi up here and I pi, and down here to minus I pi, it should be a circle with the of radius e squared. So that line over here would be mapped as a circle, or half a circle, actually all the way around here, because we did go to minus I pi down here.